Hello. So today we're going to start one more topic on friction, and the topic is block on blocks. Say I have told you that the friction questions from friction can be a little bit more conceptual. This is where it comes. This is the most conceptual part of friction, that is block on block. Block on block means two blocks will be there, one over another. One block is like this, another block is like this. Okay, and this is the contact surface. So this is the contact surface. This is block A. This is block B. Say we know that the questions which appeared in GATE were somewhat conceptual. So whenever it comes to concept, GATE questions can be always conceptual. So this is the conceptual part. Why? We'll see. This is a conceptual part, so questions can be asked from this part. So that is why see very carefully what I'm trying to tell. If this is a block A, block B, suppose there is a force F given like this. Okay. Now block A, suppose it is a 10 kg mass, suppose this is a 15 kg mass. He will ask what is the minimum force for which this two blocks will move, or what is the minimum force for which these two blocks or what is the maximum force for which these two blocks will move together, or what is the range of force because of which these two blocks will be moving together, or after which amount of force these two blocks will move separately, or what is the force given by this in between this contact, the contact of A and B, what is the force generated, or what is the force given by this surface to the block B. Such kind of so many type of question can be asked, and the concept within that can be difficult if you don't understand it clearly. If you just do it just like if you try to remember it, then also you may face problem while doing the question, because for myself I have also faced problem in this topic. It was not so easy to understand, but the way I will tell you these things, if you remember it this way, then it will be very simple and very easy for you to understand the concept within that. Where we make mistake, I will also do the mistake in here. So I can show you where we do mistake and where the mistakes comes. So once or twice I will do the mistake myself. After that we'll solve. What kind of question can become okay, that is one that will we see. But first of all the concept. The concept behind this is one force will be given like this. See, this is block A. This is block A. Okay. If this is a force, then what force could be there on the bottom of block A? Only one force. See, this block will try to move, this force will try to move this block in this direction. While moving, this block will try to take him along with him, because there is a frictional force between these two surfaces. So a frictional force will be acting like this on block A, and what is that? Force on A by B. Clear? Force on A by B. That means when it is moving in this direction, it is trying to take this also along with him. But another force will be generated in the opposite direction, that is the resistance given by the block A, because this block will try to oppose the relative motion of this block B. Block A will be giving some frictional resistance to block B in the opposite direction like this. What it should be? Force on B by A. When it will be in equilibrium, force on A by B is equal to force on B by A for equilibrium of force. But another force will be coming to this surface, that is force given, frictional resistance given by the surface on block B, and this F should be acting like this. Okay. Now if this F is more than the frictional resistance given by surface on B, then it will start moving. Always remember, it is not about these two processes. When it will start to move, when F is greater than FSB, then only it will start to move. Why? Because this force will not come at that time. When this is just try to move now, at that portion this FBA will be 0 or tends to 0. So always remember, it is only about this force and this force when it will just start to move. After, when it starts to move, after a very minimum to minimum acceleration, this force will come, but initially this force will be 0. Okay, this is the concept behind this. We'll start doing one by one questions, and we'll see where we do the mistake, where how to solve this question. And if you listen to me carefully, then I can assure you that you will not do the mistake in the question in the exam. First question, probably it appeared in some of the GATE exam. The question was like this: 1 in 100 kg, another is 150 kg. This is the surface. Coefficient of friction 0.4 in here, also 0.4 in here. This is kg. Here is a wall. Say one inextensible string is in here. Okay, this string is holding this block and in its position. Now he has asked what is the frictional resistance, or what is the minimum force. If we apply the minimum force, what should be the value of the minimum force for which block B will start to move? This is block A, this is block B. For what minimum force the block B will just start to move? So see, if this is block A, then the weight of block A will be acting like this. 100 kg is, say I am taking G is equal to 10, so 100 into 10 is 1000 Newton. 100 kg into 10, I am taking it as 10, 1000 Newton. The normal will be acting like this. Okay, we know what is the frictional resistance or frictional force given by B on A. This is in this direction. Look at the direction. It is in this direction. Why? When the force on the block B will start to move, it will try to take this block with him. Okay, so a force will be given to block A in this direction. Clear? So this direction is 1000 into what is the normal. So mu into normal, we know that is the frictional force. Mu into n, so mu is 0.4, n is 1000. That is 0.4 into 1000. That is equal to 400 Newton. 400 Newton will be the force given by block B on block A. Again, if I talk about block B, then exactly the opposite, in the opposite direction, block A will be giving force on block B. So this is the force in this direction, F on B by A. Why? Because while it is moving in this direction, block A will try to oppose the movement of block B. If it happens, then in this direction, the opposite direction, block A is trying to stop the movement of block B, but it has got a limit, and that limit is force on B by A. That I have written FBA, and that is from symmetry 400 Newton. 400 Newton is the force. This is the maximum force it can offer. Okay. So after 400 Newton, if it crosses the 400 Newton, then it has got its limiting value. Then there will be no more resistance given by block A. Again, there is one more resistance is there. This bottom surface. Bottom surface is also having a coefficient of friction of 0.4. We know what is the resistance. Resistance is mu times n. So what is the normal? See, what is the normal? The total weight. Total weight of this and this. This is the total force acting. Okay, not only the force of this, not only this. Total 100 and 150. That is 250 kg. I am taking it as 250 into 10. That is 2500 Newton in this direction. Okay. So for this, what will be the resistance in this direction? Why again this direction? Because the block B is trying to move in this direction. This surface will try to oppose its relative motion. There is a motion. The surface will be giving a force in this direction. Will try to oppose the movement of the relative motion of the block B. So how much force it can give? If it is 2500 Newton, then it will be mu times n. Mu times n is 0.4 times 2500. So that is 4 by 10 into 2500. That is 1000 Newton. So 1000 Newton is the maximum force that can be offered by the surface on block B. Force on B by the surface. Okay. So what should be the minimum force? What should be the minimum force required to move the block from the symmetry? You can see in this direction if mean is acting. So from summation of all horizontal forces equal to 0, we can get F mean minus, in this direction positive, in this direction taking negative, minus 400 Newton minus 1000 Newton. This is 400, this is 1000, should be equal to 0. F mean should be equal to 1400 Newton. So this is the minimum force which is required to pull the block, to pull this block. And the block A will not be moving. Why? Because it is attached with a string. In this string is also inextensible. So that is why it will be staying in its position, and that is why this much force will be required. I hope you can understand.